Have you ever figured out how something complicated works by observing the system carefully and inferring from what you've seen to understand what you haven't yet seen? That's a type of reasoning we call design triangulation. This method is widely used in biology to predict the functional features of cells or organisms before they've actually been seen. This employs key assumptions about design rationality that only make sense if intelligent design is true. Coming up on today's edition of Origins, Design Triangulation with Dr. Paul Nelson. Hello and welcome to Origins. I'm Ray Heiple. It's an honor to be your host today. During this program, we showcase interesting guests who present evidence from science along with other important facts, validating the truth of creation and the accuracy of the Bible. Our guest today, Dr. Paul Nelson, studied evolutionary theory and the philosophy of science at the University of Chicago. He's currently a senior fellow of the Discovery Institute and adjunct professor in science and religion at Biola University. Paul's been involved in the intelligent design debate internationally for more than 2 decades. Paul, it's great to have you again.
Wonderful to be here.
Design triangulation. Normally I can sort of figure out what we're going to talk about, but I have no idea today.
Okay, this is not that strange an idea, but it does take a little introduction. So let's begin at the beginning, actually the very beginning of the universe. And let's say that the naturalist or materialist philosophy of nature is right, okay? That the universe begins with primordial randomness, and we're just lucky to be here, okay? Now let's contrast that with a theistic view that the universe begins not with randomness or chaos, but with a mind, with what we could call primordial rationality. Those two viewpoints give you very different expectations when you do science. We can compare them. So let's start with primordial randomness. What's the default expectation under that view? This one. Well, it's that we're just lucky to be here, okay? That luck is the source of anything that we would call functional. Think about Darwinian theory. You've got random mutations occurring in DNA. Every now and then they hit on a better arrangement. Natural selection operates, and eventually we end up with brains and eyes and all these complex structures that we see in living things. But chaos is the ground state.
That's right. No intention, no mind, no principle or purpose. It just happened.
It just happened. Okay, now let's compare that to, I think, a much healthier or more powerful starting point, which is primordial rationality. And I say healthier and more powerful because I think it actually leads to greater knowledge. It gives us what we want science to yield. Now here, the default expectation is that function is caused by a designing mind, and therefore it's likely to exist even if we haven't seen it yet. So if we begin with the view that God as designer is behind everything that we see, we know how designers act. They put functions in, even subtle functions that may not be obvious, so that underwrites our project of going and looking for them.
So there should be purpose at this point, right? There should be intention, there should be goals, there should be a direction. We should see things maybe working together.
That's right. And if we don't see them, even if they're hard to find, we have a reasonable expectation that they're there. So let me show you how this works with an idea I call design triangulation. This is what's puzzling you, but I think I can make it accessible, all right? So here's the principle. When you discover a complex system performing specialized functions, infer or conclude that a rational logic and well-matched parts are providing the functions, and this is the kicker. This is where science really pays off. Even if you haven't seen them yet, you can be sure that they're there. So why should you think that? Well, universally in our experience, when we seize these specialized functions, We know that that requires rational foresight, design, and actualization. You've got to bring them into existence. So you see the functions in some living thing. You can be strongly certain, in fact, very certain, that the active features, the parts and the functional logic, are present. Now, you might say, this is what's not happening. You could call this a no magic principle, right? That this little remote in my hand or this electronic pen that I have, they're not working by magic. Even if I don't know exactly how this operates, I can be sure that there's a rational logic underlying it. So we can call this more simply just the no magic principle. Now, triangulation comes in the following way. In its literal sense, it's a mathematical relationship. I remember measuring the height of a flagpole in middle school in terms of its shadow. And there are mathematical relationships here in a triangle, a 90-degree triangle, right triangle, that you can use. Measure this, and you can infer that with mathematical accuracy. So that's the literal sense of triangulation, but I'm going to use it as a metaphor for scientific discovery, where we know A, we know B, and A and B are facts about the world that have some relationship to each other, and from A and B we can triangulate to C and say, well, look, if A and B are true, something like C is probably the case. So that's how I'll employ this term design triangulation. Now, everybody does this on a daily basis. You might not give it this name, but you see something, A is the case and B is the case. Well, if A and B are true, something like C is probably true also. So let me give you an example of this in biology. Free copper is a poison. You do not want copper ions sloshing around your cells, because they're highly reactive and they can create all kinds of mischief. All right, that's A. Now, B. Copper is absolutely required for aerobic organisms like us. So in the enzymes of your respiratory pathways, there are copper atoms that are involved at key stages. You've got to have it. If you are an air-breathing organism like us, you've got to have copper. Now, you can do this, right? If A is true, namely copper is a poison, but you absolutely have to have it, what must be the case in your cells that process copper?
Well, there has to be something there that neutralizes the poison or protects me from it.
Okay, think about my little pointer here literally is a copper ion. So I've got to bind it, your term neutralize, right? I've got to control it. But let's say my enzyme is over here. What do I need to be able to do? If my copper ion's here, but the enzyme where it's going to be a cofactor is over here.
We've got to bring them together somehow.
You've got to move it. You've got to have transport. Now I've moved it over there, but it's got to go into the enzyme, into the site where it's going to be working. So I've bound it, but what do I have to do?
You have some kind of delivery system.
I got to release it, right? So if A is true and B is true, we can be very certain that a cellular system must exist that does what we just described: binds, controls, transports, and releases copper where the metal is needed. Now, you might be a skeptic and say, well, how can you be sure of that? Well, here's how you can be sure. You can go looking for it because there's no magic, all right? Our cells are complex functional systems, and they're not working by magic. If you see these complex functions being performed, you can take that design triangulation principle and be sure that there's something there doing that job. Okay, we can go looking, it's there. Now, this was established as a kind of existence proof long before the system was actually observed. So if you go in the scientific literature, I won't read this whole thing, but I'll explain what they're saying. The scientists who comment on the discovery of this system said, we've got a problem. Copper is absolutely required, but it's also highly toxic. What that means is there's got to be something that is transporting copper ions in a way that's controlled so they're not killing the cells where they're needed. But they go on to point out, we didn't know what was doing that job. These mechanisms, these actors at the cellular level remained largely unknown, even though we knew they had to be there. So even though they didn't know what was doing the job, they knew it was there because they applied this principle, design triangulation. You see complex functions, those require specialized parts in a relational, rational logic. You can be sure they're there even if you haven't seen them yet. And here's the system, with all the features that we knew had to be there. Over here we've got our copper ions. They're being transported into the cell, carefully taken by this system. Over here where they're released, this little cartoon shows that precise mechanism. All the features necessary were there. And in fact, their discovery was underwritten by that principle of design triangulation. And in fact, when you read the paper where the discovery is described, it's just amazing the language that they use. Again, I won't read all of this. I'll summarize what's here. They say this is not happening by what they call spontaneous self-assembly. The trafficking, the movement, the control, all those are done by specialized actors. And we knew that they were there even if we hadn't yet seen them. All right, now let me apply this in a more interesting way to a story involving these two guys. Francis Crick, James Watson. At about the time they discovered the molecular structure of DNA, Crick will be the hero of our story, Watson will be the villain. All right, now, let's go back to the mid-1950s when there was a puzzle in molecular biology. It was known that DNA carried hereditary information and that amino acids that go into proteins did most of the work in cells. Now, DNA is a remarkable molecule for storing information, but chemically it's rather boring. You've got the same structure over and over. A sugar phosphate backbone with hydrogen bonds as the rungs of the ladder. Look at these guys, they're different. Some are big, some are small. The way they are assembled in proteins, these particular actors, if you will, need to be picked out of the cellular soup by this molecule. But Crick looks at this and he says, how's that happening? This chemistry is exactly the same, yet these guys are very different. So he scratches his head. He says, look, what I find, what he says, calls profoundly disturbing is I can't conceive of any structure for either nucleic acid, so he's talking about DNA and RNA, acting as a template for the amino acids. No one looking at DNA or RNA would think of them as templates for amino acids. Why? Because the amino acids are very different one from another. He says, where are the knobbly hydrophobic surfaces to distinguish valine from leucine or isoleucine? Where are the charged groups and so forth? What the DNA does show, he says, is a specific pattern of hydrogen bonds and very little else. So the functional puzzle he cracks by using the principle of design triangulation. Again, when you discover a complex system performing specialized functions, assume that a rational logic and well-matched parts are providing those functions.
So he assumed there had to be a purpose, there had to be design, there had to be functionality here, that this wasn't just random chaos happening.
It wasn't random chaos and it wasn't magic, all right? That idea of magic, which is things happen just because, is the enemy of science. Mm-hmm. To break through and to gain knowledge, you have to knock magic down and say, no, there's a rational logic here, we'll find out what it is.
There's a reason, there's a cause, and we can discover it by looking at the facts.
That's exactly right. So Crick triangulates. He says, we know that DNA carries hereditary information, but it's chemically nonspecific or boring. Yet amino acids are all different one from another, and we know that they're playing a role in proteins. If A is true and B is true, something like C must be the case. We can go looking for it. Because something is mediating information transfer from here, the realm of nucleic acid, to here, the realm of amino acids. So he triangulates. Now remember, there's no evidence yet for what he's going to describe. But he says each amino acid would need a special enzyme to combine with it, and a small molecule that has a specific hydrogen bonding surface. That's going to interact with the DNA and the RNA. And we would need 20 of these, one for each amino acid. He calls them adapters. So let's take just valine, all right? There's what he postulates must exist to connect these two realms of information. It would need a nucleic acid binding surface to attach here, and it would need to attach at the other end with a specific enzyme that grabs just valine, okay, and attaches it here to the adapter. And you'd need 20 of them, one for each amino acid. Now, he says, there's no evidence yet, it doesn't matter. these small molecules have to exist because the inference from system-level functional necessity is very strong. What that means is cells are not working by magic. There's got to be something doing that job. And Crick says, look, we haven't seen them yet, but we know they've got to be there. All right, there it is, transfer RNA. It has all the features that Crick said would need to be there. Here is the DNA, or actually RNA binding surface, right down there. Here is where the amino acid attaches, and this relationship is specific. It's actually a true code. These three letters in DNA and RNA mean this particular amino acid. Now, this was isolated and characterized many years after Crick predicted its existence.
So Crick never saw transferred RNA, but he said something like this has to be there. From what I see, I know this has to be there as well.
Right. In effect, he says something like this must be present in cells because they're not running by magic. We can go looking for it. What's remarkable to me about this is he did this in the complete absence of any evidence for this molecule. That's an amazing feat.
Completely by inference.
Completely by inference, but a strong inference because cells are not working by magic.
There has to be a rational cause.
There has to be a rational cause. There has to be a rational logic. Now, the villain of the piece. James Watson never accepted this hypothesis until it was obvious that it had to be true. When he first met it, he said, I can't.
Welcome back to Origins. We're talking to Dr. Paul Nelson, who's been sharing some fascinating things about design triangulation. You know, that's something all human beings do when we look at a couple of facts and we, with our minds, infer something that we haven't even seen yet. So, Paul, where did we leave off?
All right, let's go back to 1955. James Watson and Francis Crick, who won the Nobel Prize for discovering the molecular structure of DNA, they're close friends. And in that year, Crick predicted the existence of a molecule in cells that was essential, but nobody had seen it yet. So he did what you just described. He took fact A about the structure of DNA and fact B about amino acids, which are related functionally. And he said, this chemistry is very regular. This chemistry of amino acids is very irregular. How is that information being transferred or mediated between those two realms? So he said there must be a molecule that does that job somewhere in the middle that connects with DNA and RNA on the one hand and amino acids on the other. It was a beautiful prediction. The problem is James Watson didn't buy it. But his reason for not buying it is very interesting. Now, Crick called this the adapter hypothesis. That was that molecule in the middle, okay? And Watson, often complained that Crick talked too much, but that wasn't his reason, all right?
So they didn't like each other.
Well, they were close friends, but Crick did talk a lot. And Watson, though, had a very specific reason for rejecting the adapter hypothesis. Okay. Here's what he said. In his own autobiography, he said, I did not like the idea at all. More to the point, the adapter hypothesis mechanism that Crick inferred and actually was discovered later, seemed to me too complicated to have ever evolved at the origin of life.
Wow, that's telling.
You know what? It's not the biological evidence itself. The biological evidence pointed to the fact that there had to be a molecule like this. Rather, Watson's biological intuition was constrained by an implicit time axis. What I mean by that is there was a particular story that he had to tell about the origin of life. And if that story wasn't true, Watson was going to have problems. So here's the way to think about it. Time is the villain of the piece in Watson's imagination because complexity, molecular complexity is present in any cell, can only be built one step at a time. Okay? And in the Darwinian picture of life, which Watson accepted, biological systems can't arise all at once. That's impossible. So if evolution is proceeding along a timeline, and evolution is just one thing after another, that would be true also of the origin of life. And it certainly was the case for Watson. Biological complexity can only accrete slowly over long periods of time. So Crick has this hypothesis, and Watson says, I already know that DNA and RNA are there as information carriers. They're storing the information. I already know that proteins are doing most of the work in cells, and they're built of amino acids. And he says to Crick, you want me to accept that there's another thing in here between these two, and all of this is present at the same moment in time? He says, no way. That's just too much complexity to have all at once. So he says, this can't be. That can't be true. It can't happen at the origin of life. It's too complicated. This isn't based on evidence.
No, it's not. He didn't like where the evidence led.
He did not like where the evidence led, because the evidence that Crick had accumulated that led him to predict these so-called adapters that turned out to be transfer RNA, that evidence was very, very strong. Watson was a slave, to be blunt about it, to this time axis, to this evolutionary story that he had to tell, and he got it wrong. In fact, he did this. But this is real. Every cell in your body that makes proteins has transfer RNA molecules.
Now, did both of those men live to see the discovery of this molecule?
Yes, they did. In fact, a few years after Crick predicted its existence, transfer RNA was isolated and characterized, and it had all the features he said would need to be there.
So what does Watson say at that point? Do you know? Or?
He admits he blew it. But what's interesting to me, looking at this episode as an intelligent design theorist, is why did he get it wrong? He got it wrong because of this. You know, an intelligent designer doesn't have to be bound by a time axis. When you want to make something new, what's the first thing in your mind?
Well, I think of the end product. What is it going to look like at the end?
That's right. You have an idea. It's not an actual material thing. It's an idea that's out there, and you aim towards that idea. So the idea, the concept is primary. So you're not bound by time. You're only bound by the limits of your imagination. And you say, well, it'd be nice to have a device that does this, right? That lets Paul advance his slides. Or a device like this. Or the cameras that are filming us right now. You conceive of the target, and then you work towards it. So you're not bound by time the way an evolutionary process would be. An intelligent designer does not need to be bound by time, and the parts do not need to precede the whole. You can conceive the endpoint and then aim at it. And I think in the case of Crick, he got it right. And he's a hero of mine, I'll be honest. As I look at his career, from his early days as a physicist through the development of molecular biology, right on through, he did his best work when he thought as a design theorist. And frankly, he did his worst work when he thought as a Darwinian. When, like his colleague James Watson, he chained his imagination to a time axis. I think biology presents us with a world brought about by an intelligence who visualized the endpoints and then actualized them. Wasn't a slave to time. Things didn't have to happen in a certain order. And I think that's knowledge, and that's what science should be seeking.
How do evolutionists justify these limitations that they're putting on when they exclude possibilities that really the facts could be leading them to? How do they justify that?
Well, I think we need to be very hard-nosed about the reality that science and philosophy and theology interconnect. And I think all of us want the world to be a certain way. I think what we are obliged to do is to serve truth. And if we let her guide us and say, we're going to uphold truth, we're going to seek wisdom, we can avoid some of these errors. I think in the case of James Watson, he's very candid, and I admire his honesty to say, my view of the origin of life would not allow me to say that these adapters existed. So his conviction that a certain materialistic story had to be true about history ended up leading him into error with respect to cell biology. So an important message of this principle of design triangulation is if you let the evidence be your guide, and if you serve truth in your spirit and in your intellect, as Solomon said in Proverbs, wisdom will guide you.
You know, Paul, you're a scientist, I'm a pastor. I can't help but think of what Jesus said, I came to bear witness of the truth.
Amen.
And everyone who is of the truth hears my voice.
Amen.
Isn't that the essence of what it means really to be human, that we should be seeking the truth wherever it lies?
And you know what? Truth, if I can personify her, she honors that.
Yes. Well, thank you for being with us, Paul. Really
Always
appreciate
a pleasure.
it. I hope you enjoyed today's program. We looked at a complex subject in a way, design triangulation, but really it's something that we all do all the time. It's just to think rationally. When you see fact A and you see fact B, and you realize with your mind there has to be a connector, there has to be a source, there has to be a cause. Well, it just goes to show what we see in the Bible. There is a creation, there is a creator. We know that creator is God. You and I, we know what the Bible says is true, and the proof is all around you. Thanks for joining us for this edition of Origins. We'll see you next time.
Thank you for watching this edition of Origins. For a DVD of this series, you can order online or send a $12 donation to cover shipping and handling, and write to Origins Program, number 1904, Cornerstone Network, Wall, Pennsylvania, 15148.
This presentation was made possible by the faithful prayers and financial support of you, our Cornerstone family.